Hello, Say Geeks. Welcome back, and welcome for new if you are new to the channel. So today we finally set up end-to-end a virtual node in your Kubernetes cluster, allowing you to submit a Slurm job on a remote batch system. So how cool is that? So before going through the details and recap what we did last time, just take a bit of time, a couple of minutes to chill out, say hi in the chat if you want to, or present yourself or ask questions regarding the last episodes. So I put some music on and just drop a message, say how, present yourself if you want. Let me just put on some music. Hopefully you can hear that. I'll start. Hello, welcome. Say hi. If you want. If you want to. All right. Hello, Taganurov. Hope I pronounced that correctly. So we already talked to each other earlier today, and hope you enjoy the guide. It's basically a step-by-step guide of the Slurm installation. And the Slurm installation is already done on the last episode, so on the VM, but it's usual Slurm batch installed on a VM. Today we are going to take from where we left, so we install all the chain starting from the installation script of Interlink, that is the tool that is going to be used for the virtual kubelet, and then and then we make our first job in Slurm running. Okay. How is the music, by the way? Too high, too low? It's fine. Hearable at all? All right. So if you can hear me well, if not, please let me know in the chat. I'm going ahead. Yeah, just a couple of seconds. I see people connecting. So say hi if you want. Yeah. Okay. Good. So 30 seconds and we are kickstarting our journey. Let's see. Yeah, if someone else want to say hi and present himself, otherwise we go ahead. All right, 30 seconds just passed. So we move on and we go to the usual schema that we produced in the first episodes. So today we are finalizing, eventually, the setup of this blue box that we presented last time. Very briefly, I'm recapping what we are doing. So we have a Kubernetes cluster on a civo.com provider. So a normal Kubernetes cluster. At the end of the episode, I will reproduce very quickly the very same thing on a Minikube instance. So it does not require any special thing from the Kubernetes cluster perspective. And that's the cool thing. And I hope you enjoy that. So then you have a series of node, and these nodes 1, 2, and 3 are the physical nodes of the cluster. The idea is to produce a virtual node, meaning that you can associate a pod to this kind of machinery, and via some magic you can translate this pod into a container that is executed somewhere else. And somewhere else can be many things, but for instance in science we have possibility to access supercomputer, and supercomputer usually comes at the cost of not being able or running Kubernetes on that many resources, so you will end up needing HPC centers to be accessible through a batch system. And at least in main Euro HPC centers, Slurm batch system is the one that you are going to find there. So we start from there. We start from a virtual kubelet able to talk Slurm. And to do that, we simulate this in a sandbox, if you wish. And the sandbox is made by a virtual machine where we install manually a Slurm batch system, so we have full control. You can see there are no weird tricks underneath. And we install Slurm plus Slurm plus a container runtime. That's the only requirement. The remote counterpart of the virtual kubelet has to be able to run containers. So we install Obtainer. That is again a usual choice for HPC centers. So far so good. The tool that does the magic is a provider built on top of virtual kubelet. That is a technology of the Cloud Native Computing Foundation. So it's well known and maintained. Not as much as it should. So we are trying to push this further. We are trying to streamline the creation of your own virtual kubelet, or your own logic behind virtual kubelet. Nevertheless, we also provide our vision. So we provide also ready to work Slurm plugin that we are going to use this time. So for whoever just connected and lost first episode, first of all, subscribe and go to the first episode to take a look. And then I pass here in the chat, then I'll put it into the comments, the reference to the guide that we are going to use. Interlink is the tool. It's a software developed at INFN, that is the National Institute of Nuclear Physics in Italy, and in the context of a digital twin project, so European project that is called Intertwin. So you find all the details in the presentation I shared before. So alright, so you go to the documentation, you have guides, and inside the guides you have step-by-step increasing difficulties. So you start from a bare installation. That is what we are going to do today. Alright, cool. So good. And the first step is creating a client in a GitHub, your GitHub repository. This is needed because the structure of this provider is pretty simple. You have the part in your cluster, the purple one. Let me increase the size. Yeah, the purple one, that is the virtual kubelet, should be able to talk to the remote counterpart. And the remote counterpart communication should be authenticated. So we use auth to proxy to authenticate the request. The virtual kubelet provides a token for any request that is validated at this level, and the orange level here, down here. So we need to instantiate something. The default guide is talking GitHub because everyone nowadays has a GitHub account, but you have also examples for other providers. And next up, then we install with a script, with the installation script, we are going to have a manifest to install the virtual kubelet pod, and a setup script for the remote interlink part. So this API server will be brought up via a script that is produced by the installation script. And eventually we are going to set up, that is a bit the most tricky part, because the plugin structure foresee that many of these plugins should be produced by yourself or custom in any way. So it can be very dependent on the way people produce their plugin. So we are going through something that is well maintained and we use daily, that is the Slurm plugin. Alright, so that's it. We go to the first step. We take back our guides, and from guides we do deploy interlink virtual nodes. So as I mentioned before, you should get a valid client for OAuth2 authentication through GitHub, and here you have step by step. You can get it wrong. You fill everything here. I already did it, so we do not lose too much time, and either I share secrets with you. So we go ahead. Take your time when you try to do this on your own, and if you find any issue, you have in the documentation also the link to the support chat, that is a Slack channel that you can join to ask a question there. Hello, super programmist. Welcome to the SciGeeks universe. Yeah, so we just started and I introduced what we are going to do, so you can get on board pretty quickly. We didn't do a single command yet, so yeah. Okay, now it's time to start. We have, as I mentioned before, an installation script. Okay, yeah, and you can select your preferred version and install it on your local laptop, for instance. So let's take from here and consider that the release page will be the one that you should refer to take the last good version of the software. That is not the one that you find in documentation. This is the first caveat. You know, it's a development software. It's not really easy to keep everything. So just refer every time to the latest release that you find available in the GitHub repository of the project. So last time we already produced a Sivo.com development cluster. Very quick, very easy, very cheap, so you can do it on your own. And then voila, we have a kube ctl get node, and we have two physical nodes on our cluster. We are going to install a third one, that is our virtual kubelet. What does this mean? It means that we are going to install the latest version of our software and of our installation software. And right, already did this, so I shouldn't do this again. But just to let you know that the correct version to use at the moment is this one. Is this one. Releases, you go to the releases. The latest one is the release candidate 5 or 0.3. You see, we are pretty early in the development, so let's go ahead and you download. For instance, I am on a macOS on a Silicon. You can, and I will be able to use this release. Otherwise, you choose your architectures. Okay, and you will end up anyway with interlink install executable downloaded and ready to go. Then I'm going quickly because it was part of the last time episode, so just we're going to follow up from where we left. Then you can do an init script to create an empty or, well, a skeleton of the interlink configuration that consists mainly in the details on how to contact the remote server that is responsible to translate pods into Slurm submission actions. Then the version that you want to use in the interlink version, the kubelet node name, so the name of the virtual node that will appear on your cluster, the namespace where the installation will go, and the resources that will appear as allocatable into the node. So here you see that this is a pretty standard pretty standard configuration, very static. We will have some ways to make it dynamically, so advertise for more resources at the node level, but yeah, so far that's the application. And then you define the OAuth authentication with the remote SAT. So you define what goes in here, so how the node appears to the Kubernetes cluster, and the second part is how to authenticate with the orange box if you want. Alright, and you have all the details that you get before in the step-by-step. So, alright, and cool, so yeah, I'm looking at the chat. Okay, so let's see how a configuration script that should work appears. Interlink and config. So you see here I have to tab. Let me increase the size, sorry. Okay, so here I have to tab. The upper one is the one on my laptop, so the Kubernetes one, and this one is the machine that I instantiated last time, so the remote machine on Cibo provider. Let's take a look first of all to the configuration script. Oops, sorry. Come on. Okay. So the configuration script indicate the API endpoint, the interlink version, and so on and so forth. I'm going to cancel the client ID very soon, so don't try to copy it. And Slurm remote node is the name of the virtual node that will appear. So let's take this example, that is the one that you find in the guide, nothing more, nothing less. And you can do interlink install. What will happen is the following. Oops, no, sorry. I'm going to put the results here so we can follow up better. And to do that, we need to say, okay, configuration and output dir. So we are going to pass ---- config and the name of the configuration, that is interlink config.yaml. And then we want all the output of this installation script into output dir. You want it to be here, for instance, install refs. Okay. As you can see, it's configured to get the your codes, your tokens from GitHub. So you should be able to follow up the request of the GitHub. So you go to this address, you put there the code, and then voila, I did it on another page, so you won't be able to see it. But now, yeah, I validated, I am here, you can get my token, and that's all. So you are ready to go. And yeah, so now, as you may see, there is a step-by-step guide for you already produced as an output. And what you have to do is simply follow up with the information you find here. So first of all, install the manifest. The manifest is going to install this part. That is the, let me go back to the overview. Yeah, to the introduction. So with the manifest, you are going to install the part that runs inside your Kubernetes cluster. And then we have an installation script that is running on the remote host. So is the interlink API same as the IP? Let me just share the question. Okay, is it same as the IP of the external systems? Yeah, sure. So the interlink API is the API of the remote host. So in my case, is the VM running a Slurm HPC system. That has just one requirement: should be reachable from the Kubernetes cluster and should have one open port. That in this case is the 30443 in my example. So these are just the two requirements that you have. So definitely interlink IP is the IP of the remote host, capable of receiving information, or let's say requests from the Kubernetes API server. Right? So hope this answers your question. Let's go ahead and cool. So let's try to install our first virtual kubelet, right? Are you ready? Should have some more tense music, but yeah, let's try. kubectl, apply, you install a lot of things, the namespace, the service account to allow your pods to register as a node, and eventually you will end up with a get pod -n interlink, that is the namespace you indicated in configuration, and you end up with this running good. And if you do get node, you see here Slurm remote node ready. Okay, ready will be turned to unready pretty soon because we do not have the remote counterpart running, so it won't be able, you see, to connect to the remote part. But so far so good. This means that our first achievement was reached. That means the purple box here is working. So it's talking with the Kubernetes API server. It's saying, hello, I am a virtual node. You can use me to send the pod that you want. Then there is the remote part. How you do the remote part? The remote part is pretty simple. You copy the interlink. No, it's not called setup anymore. It's called install ref interlink remote sh, and you copy it into your remote server. That is the one that will run the interlink API server. Cool. Now once here, what you have to do is to do interlink remote.sh, and first of all the install, that we install all the binaries needed to be run and create the subsign certificate. So yeah, that's good. We have everything set up. And then you need to start the daemons. This is the second step. So with the start command, we are going to complete the following. We are going to complete the orange box, meaning that we will have two processes. You know, you will have this is very important. On the remote part, you will have two processes that for the communication, that are the OAuth 2 proxy, responsible for authenticating the token and the request coming from the Kubernetes server, and the interlink part. That is the translator, if you want, translating pods into simple container lifecycle command, running, deleting status, logs, and kills are 5 methods. This red box, don't imagine them as too much complicated. They are simple web server capable of doing a submission of a Slurm job, in this case, and managing the execution of a container inside these jobs. Simple as that. And this part is the third one that we are going to install. So let's go ahead, let's move on, and go with the installation of the orange boxes. Typing remote.sh start. Alright, now one important thing, debug procedures. To check if everything works, first of all, you should have two new processes that are running, one called O2 proxy and the other one interlink. And with the start configuration, the logs will be stored into .interlink logs. Here we go. So we have interlink and O2 proxy. The O2 proxy should look like this. So yeah, there is something running already somewhere that is not authenticating. I think I know what it is. So I will turn down for the moment the Minikube installation. And we are going to restart everything. So we start from scratch. Sorry about that. Okay, let me clear this up. So we do stop all the daemons and then we restart them. Okay, now exactly. Now the O2 proxy, these are the first line that are telling you, all right, cool, you did it. You finally managed to bring up O2 proxy configured correctly. And then there is interlink log, that is the other one. If you see these messages, so far so good. Everything is up and running. Then we need the third step. The third step is pretty simple again. Is installing the Slurm plugin. Before doing that, be sure that you have a working queue, Slurm queue running on your system, and you have nodes available, so everything is good. And we are going to start the installation of the final step, where you can find this in the documentation. This is the other important part. You can find the documentation about the installation of Slurm some step below where we were. So here you install the interlink part, or blah blah blah, you copy the remote SH to the remote site, and good. So now you're ready to either develop your own plugin and talk with the interlink part, or to use something that is already ready. And what is already ready is the remote Slurm submission. And to do that, again, just be sure to take the latest Slurm release. That is the one here, 03. Let me check. Yeah, 031 should be. Oh gosh, I'm not sure anymore. Yeah, it should be this one. So you download this plugin, and let me exactly. So you download this plugin. Oh. Yeah, exactly. You get export version 031. You go ahead and then you download that wherever you want in principle, but the guide that I showed you before, this one, will tell you, this one will tell you to put your plugin in that folder, and it will look for that in that path. So to be sure, just go ahead and put into home interlink bin Slurm plugin. All right, already did that, but so let's take a look. Alias interlink bin Slurm plugin, and voila. So we have that there. Then the other part that you need is the configuration of the plugin itself, and it will look quite straightforward. So you should put a configuration file like this. Actually, if you run this documentation, you should touch pretty much anything here other than the root folder for all the information on the jobs. So this path will change, of course. And in fact, if we look to our case, if I print the content there, you see that the configuration is exactly the same as I showed you before, but the path for the root folder is different. So I want the jobs detail to go into the .interlink part. All the rest stay the same. All right, cool. Then we miss just one final step. Be patient, brace yourself. We are almost there. Yeah, don't forget the slash at the end of the data root folder. We are going to fix this very soon, but yeah, please include a slash at the end. Okay, this is the latest plugin. You can copy everything I did. It's documented here, so you can reproduce it. And if not, please let me know. Okay, and then there is, in this example, we run a systemd user level unit to execute our plugin. You can see here it's nothing too fancy. We set some environment variables. We tell the Slurm plugin where to look for the configuration, and eventually we execute the binary. So that's all. Really, that's all. You can find all the commands here. You can execute and copy, and eventually conclude the execution with a situation like this. Okay. So you have the exact start, the binary that we downloaded, the configuration, and where to put the output. That's really all. Nothing special, nothing mad. And now we are finally ready. Let me check. We did restore the daemons. Yes. Okay, cool. And so we are ready to enable our systemd units. Here, actually. Yeah. So we reload and we enable our Slurm plugin, systemd, and then we're going to start. Ready? Let's see if it started correctly. To debug this, so user status running, and in case it fails, you will find the logs in the very same location as the previous ones. So plugin. Cool. So it's loading. That's perfectly working. We have all the set of the puzzle in place. So we are going to do a cool thing. Give me some. Okay, we are going to delete our deployment of the node. Give him some time, and then we are going to, we're going to set up that again. So we can see how the node will go in ready, stay in ready, and we have, meanwhile, while this is deleting, we can take a look of an example. This is a pod. Oops. This is a pod that is meant to be executed on the Slurm endpoint. And what it takes to do that? Well, some annotation to tell, for instance, the HPC center to download the image through Obtainer from a Docker, from a container registry, not from a Singularity native image. And then, so a single annotation, look, and then the only other thing that you need is telling, okay, I know this is a virtual node. This is what I'm telling here. So I know this is a virtual node. I don't care. I want the 100 GPUs that are running inside that supercomputer. So I take the risk of not being fully compatible with what I can do on the pod. This is the meaning of the toleration. If I do not explicitly say the toleration, the pod won't be scheduled on the virtual node. Never. And the other part is indeed the node selector. Node selector saying, look, I want to go to the node called Slurm remote node. This pod in particular will stay sleeping for 100 seconds and then will go and say, I'm finished. All the rest is a simple normal pod, right? Right, we are going to apply this pod to our cluster and see magically, not really magically, but a Slurm job running on the remote host. Are you curious? Yeah, me as well. Let me see where we are here. Perfect, so we can apply our manifest. Hopefully, yeah, they go up running immediately. And we have our nodes. Voila! Slurm remote node. Let's take a look briefly to the node, describe node. Okay. We are registered, and then you see we appear to have allocatable resources that are pretty huge because we are not enforcing anything at the moment. But yeah, otherwise it's a normal node scheduled, so schedulable. And yeah, nothing else, just want to make you aware that it's just really a simple node from the perspective of the Kubernetes cluster. Then we can go ahead. Let me split the screen again. And I received a message. No, not yet. Okay, so let me split the screen again because here we will have our SQ. Oops. Come on. Typos everywhere. Okay. We have our SQ command, no jobs whatsoever. But if we do kubectl apply -f test and then get pod, so you see that now it's pending, so it's not working. Let's see, something appeared here. No, so we have some magic that is not occurring. Get node. I know what. Don't panic, don't freak out. So apply okay. It's important that the installation process happens in half an hour, because otherwise the token that you retrieve before is not valid anymore, in the GitHub use case at least. In other use cases, if you have your own identity provider, you can extend the duration so you can do whatever you want, but in this case it's not. Alright, let me do the install Again, if that happens, the only thing that you have to do is to do the install procedure again. So it will take just a few seconds, and yeah, come on. Okay, continue, authorize, and we are good. So now we should be able, and I know that because most probably we will see interlink logs out to proxy log. Yeah, you see permission denied. No valid authentication in the request. So now I do the apply here again. Exactly, now I should see here remotely that the authentication are proceeding correctly. Hopefully. Let's see if something arrived. Bad credentials. I think, Dagvanarov, this is where you are stuck, I suppose, because I can get... no, probably I know also this. Let's see, so it's good to have this done together. Interlink remote, no, YAML. All right, so I don't know why I didn't have the last version of this script. So if you find this problem as well, it's because he's using the old token stored on your local host path. So one solution is to tell, okay, empty please, and proceed further. And so if we apply this now, hopefully we see a 200 HTTP request coming out. One crash loop backoff is okay because it's retrieving the token, and now yeah, something should appear soon. Get node, oops, get node. Yeah. So if other debug int, if you're interested, since we are waiting for. All right, 200, we are ready. So if you get stuck at this level, another hint that I have is to go and get pod -n interlink and go looking at the logs of the pod. So you take this pod, do logs, and in particular you want to see the container that is called intertween virtual kubelet. Oops, 1T too much. Exactly, and if you see pinging succeeded with exit code 0, it means that the whole chain is ready. And voila, if we want to check that the whole chain eventually is ready, we should apply a pod, getting it, and see that is pending, and voila, eventually it arrives, and it's a job on an HPC center on a Slurm node that appear just like a pod that is running, right? Another debug hint, the logs of this stuff will be stored into the directory that is specified in the Slurm configuration, in the Slurm plugin configuration, and all the pods and the job will appear here in this folder. So ls minus h. So the last one is this one. And inside here, you will have the submission, the job submission, the job.sh, and you will have a lot of other configurations. So the job.sh is the job that is configured to be submitted. We can take a look at that very briefly. Come on, job.sh. Okay. Yeah, more typo, please. Okay, so it's a batch file executing a singularity command. Nothing more, nothing less. That's how the magic works. And then inside that folder, you also have the logs of your container. The logs of your container looks like this. mycontainer.out. Okay, so you see the job ran and finished. Print a finish, as I told you before. Again, I split again the screen. This is a remote machine running a Slurm batch system. Or can run whatever you want, can also run HT Condor, can run whatever kind of batch system you want, or also can be a lambda function as well, so you can decide to create a plugin for that use case. The main point that we are showing here, that we are demonstrating here, is this one. So let me go back to the full screen. Here on top you have a pod running, but instead of having a pod in a physical node, you have a pod on a virtual node that under the hood is submitting something else. For instance, a job in Slurm executing a container. But from the framework perspective, if I have a framework, and we will have machine learning framework, Gen AI framework on top of this Kubernetes cluster, everything is transparent. You can schedule on this virtual node an ML flow, a kubeflow task, for instance, that needs 4 A100 GPUs, and you can outscale, offload these payloads on this virtual node to be executed somewhere else, on a HPC center in this case. That's how cool is this. And just let me go briefly to the schema again. You see that it's not important which kind of system you have. Here the plugins we have start to be quite a lot, but the whole chain until the orange box, so the installation of the virtual node and the communication with the remote part, is the same in any use case. What changes are only the plugins at the bottom. So you can run on a big machine with a Docker, and that's already possible. Slurm, HT Condor, we have any kind of different plugin already available. If you have any particular use case, please let me know. We can work together to get started. And so, yeah, that's all. I think we reached a good point. The purpose of the episode is reached. So we have a question, and then I want just to show you the very same thing that runs not on this cluster, but instead I'm going to bring up Minikube instance. So okay, let's bootstrap. 2 pods on the same virtual nodes can communicate with each other. Yeah, good question. So it really depends on the plugin. So in the case of the Slurm plugin, they can communicate with each other, but if you make them aware that they are not normal pod. What I mean, you cannot create a service to make them call, because there is no communication between the Slurm cluster and the Kubernetes cluster. What it happens is that you know that they will end up in a Slurm system, so you can get the host name of the node, for instance, and you can use that or the IP of the container that is running and make the other pod talk to that endpoint. But again, it's not guaranteed that on a Slurm system you can do that. The other part that you can do, you can pass to the annotation. If you see what we did here, in the documentation of the Slurm plugin, you have an annotation that says Slurm options. So you can use MPI options, for example, MPI setup specifying the SBatch options at that level. So you can have two pods doing MPI stuff, for instance, because you can configure all the nitty-gritty details of the job that will be executed on Slurm through that annotation. So this is the other option. Yeah, so I don't know if that answered thoroughly, but the idea is we do not have an overlay network yet in place with this system. You have to rely on what you should be able to do, submitting jobs manually, more or less. So that's the answer. Right? All right. So then, yeah, well, just few minutes. Resist few minutes. We are almost done the hour that I have in mind. So demo platform, good. I said I start a mini cube cluster. I keep a single interlink. This is another useful stuff. You can have a single interlink, orange part, talking to multiple clusters. This is the other cool thing. So I will have a virtual node on a sivo.com cluster and also another virtual node on my Minikube on my laptop that are able to talk to the same infrastructure. This is also very, very cool. So, all right, my kubectl says, well, you are on a Minikube. Let's delete let's delete this node. There was a previous attempt that delete node. Okay, and get pod minus n interlink shouldn't be anything. Yeah, okay, and then we install again just the first point, just the purple point in the previous schema, so just this one, and voila. So we do the install again just to take another token, to use two different tokens in the two clusters, and we are ready to go. So here it is. Now I should be prompt with another manifest, and I can apply manifest. So get pod, okay, probably I need to, okay, let's see. Get node, hopefully it stays ready. So it looks okay. Let me check if we have something wrong at the O2 proxy level. No, I think everything looks good. So also here we have a Minikube and a Slurm remote node. I can apply the very same pod as before, and here on the remote node again, if I were lucky, voila, we have a different container on a different cluster running in the same Slurm remote node. So far so cool. And just one notice, you can interact with this pod like a normal one. So for instance, I can get the logs out of it without logging into the remote cluster, right? So you see, here are the logs that are similar to the ones that we saw before. And yeah, that's cool. So now give some time to print the finished message. 100 seconds, I think. So meanwhile, if you wish, we can get more questions. So let's put this here. Chat. Yeah. Okay. Any question? Anything? So let's check. Almost there, almost 100 seconds. A bit of a tense moment. And voila, finished. So we have finally a virtual node capable of doing whatever we want on a Slurm cluster. Downloading the images from a Docker Hub, for instance, and using it as an obtainer, Singularity, or whatever container runtime you have on the remote side. Thank you for staying so long. We are almost near the hour. Let me just go back to... Let me just go back to where we are with the schema and what we are going to do on the next one. So we are here. We have a civil Kubernetes cluster. Well, we also demonstrate that the very same thing can work with Minikube as well. So on your laptop. And a laptop or a provider of Kubernetes cluster, it doesn't count. Yeah, and we have another question meanwhile. Yes, if I delete the pod, so you see that now if I do this, you have this folder that is the last job, and the job is finished, so it's not here anymore, but the folder and all the data are there. If I do, instead of apply, I do a delete, the folder disappeared. So all information of the pod disappeared. So yes, delete also work on the remote side. In case the job was running, it wouldn't be cancelled also on Slurm. Okay. So yeah, taking back the schema, Kubernetes cluster with any kind of physical nodes you can extend with a virtual one, right? So the virtual one is composed by a blue bar, purple bar, whatever, that is the one responsible to fake the Kubernetes API server saying, okay, I'm a node, give me a pod, and then asking a remote counterpart, that is the orange box, the core part of Interlink, asking, okay, please execute this pod for me on any plugin that you can talk to. One of the plugins it can talk to is a Slurm plugin. So we demonstrate here that with this plugin we can submit job to a Slurm queue using a Kubernetes cluster native API. So any framework that can run on top of this can be used. And this is the next step. Next episode will focus hard on installing, getting the basics for demonstrating the frameworks that you can use on top of this. Since we want to do science, data science, I choose a selection of frameworks, and the frameworks are interactive analysis through Jupyter Hub, MLflow for tracking experiments and all the things that it can do, Kubeflow for a complete test and production of models, and then a very cool thing that we are going to use together with a provider of GPUs, so another application of a virtual kubelet, it's Helix ML. So a complete framework. If you don't know what it is, we are going to through that, and also I will introduce how it looks. So we are going to install also this one, and then for all of them 1, 2, 3, and 4, or 3B, we are seeing how seamless is to run either on a physical node or on a virtual node. So meaning that if you have this set up at infrastructure level, you can install any kind of framework you want and tell, for instance, Jupyter Hub, please spawn my Jupyter Lab session on a node on a supercomputer, on a Euro HPC center, for instance, right? And or again, on a GPU provider that where I pay just for the time that I use my GPU. Same if I want to do a Gen AI production testing thing, so I want a chatbot or whatever. Or in Kubeflow, if I only have a pipeline where some of the step in the pipeline takes more resources, I can delegate this to on-demand resources on the left or on supercomputers. So again, 1, 2, 3, and 3B will be at least 2 or 3 episodes on the next part. So we give the virtual kubelet for given, and then we focus on installing these frameworks. And I lied a little bit with to you before. They will need some tweak to automatize the node selector properties, but yeah, that's the sense of going through that. We are going to install a simple Jupyter Hub, MLflow, Kubeflow, and Helix ML, and then we are going to tweak them to make use of special node for their offloading. Let's call it this way. All right, so cool. We are almost in the hour. That was the purpose, and yeah, it's time for a couple of questions if you have, or if you have special requested. For instance, you want to start from one of these the frameworks, or you have a framework of yours that you want to be in this list. So I'm happy to follow up with your use cases. Or if you have different kind of provider, maybe this is this is an Italian provider. If you have anything else that you want to introduce or to understand how you can integrate, yeah, feel free to ask here in chat or whatever. Also, if you want to present yourself and you want to say hi, please do it in the chat. Yeah, I'm happy to see people involved. All right. Cool. So if you're curious, if you liked this episode, and if you enjoy the technology, consider that this is an early development phase tool, so you can contribute as well. It's open source. We are open to any contribution, and if you have ideas or you see something that can be done better, please get in contact. And if you don't want to lose the next episode where we are going to install all these cool frameworks and integrate them with virtual nodes, please subscribe to YouTube, Twitch, or whatever, and see you on the next video. Thank you everyone for staying so long connected, and yeah, bye bye.